Remember that in supervised learning, the machine learning model calculates or predicts the value of the target variable. However, this calculation or prediction of the target variable might not be 100% accurate. It might be close, but it might not be exact. For example, consider a weather prediction system that uses machine learning model to predict the maximum temperature that will occur on a day. So, on a particular day, the model predicts that the maximum temperature today will be 45 degrees Celsius. But as the day actually arrives and you measure the temperature, you see that the maximum temperature is 45.5 degrees Celsius. So, although the model was close, although it did a good job, there was a slight error of 0.5% in its performance. This value that the model predicted is called the predicted value, and this value that actually occurred is called the target value. And this difference between the predicted value and the target value is called the error. Now I will show you how we calculate error in machine learning. Consider a problem in which we are using machine learning to predict the test score of a student based on the number of hours studied by the student. Look at this data set. The first column shows the number of hours the student studied. The second column shows the test score of the student as predicted by our model. And the third column shows the actual test score of the student when he took the test. Now, as we are using number of hours student studied to predict his test score, the number of hours is the predictor variable and the test score is the target variable. So it is common to represent the predictor variable with an X and the target variable's predicted value with a Y hat, and the target's variable's actual value with a Y. Now, there are two ways we can calculate error. The first way is to calculate the absolute difference between the actual variable and the predictor variable. That means subtract this value from this value and take mode. That means 67 minus 63 will become 4 in this case. And we can write the formula as the second method to calculate error is considered more reliable and is used more commonly, and that is called scared error. To calculate scared error, we take the difference between the actual and predictor variable and then take its scare. So its formula can be written as, let me show you how we can calculate both these errors on this data set for each row. For your understanding, I have calculated the absolute error and the scared error for each row in this data set separately. I have applied this formula on each row to calculate absolute error and this formula to calculate scared error. You can repeat this exercise if you like. Now, we have calculated the scared error for each row. But what if we want a bigger picture? We want to judge the model's performance on the whole data set instead of individual rows. So to solve that problem, what we do? We sum up all these scared errors into one value, and that value is called the sum of scared error. This is its formula, and when we calculated it, that is when we summed up all these, the result was 34. So the sum of squared error was 34.